Hello and welcome to the DockYard Elixir Roundtable. I'm Nathan Long. I'm a staff software engineer here at DockYard.
I'm Brooklin Myers. I'm an Elixir educator here at DockYard as well.
Hey, I'm Zach Ellis. I'm a senior software engineer here at DockYard.
Mike Benz, staff software engineer here at DockYard.
Hi, I'm Rockwell Shrock, senior software engineer at DockYard.
I am Benny Rosas, and I'm a software engineer at DockYard.
I'm Andrew Berrien, and I'm an Elixir engineer here at DockYard.
Chris Tovar here, Elixir engineer here at DockYard.
Awesome. So we are going to talk about a project that Rockwell's been working on. We talked about it on a previous episode. I'll have to go back and find that episode number. But you made a really cool map, a METAR map, if that is indeed how it's said. Really cool blinking lights kind of physical project up on your wall. So if you would kind of start out by just telling us again the quick overview of what that's for.
Yeah, sure. So I talked about this the first show that I was on. Again, I don't remember the episode number either. And what it is it's a combination like hardware and software project where it's a map, physical map that's hanging on my wall with a bunch of LEDs, and the LEDs are scattered throughout the map, and they indicate the weather at different airports all throughout, my local region here in the Northeast. And it was all originally written in Elixir, and it has a little Phoenix front end web interface for controlling it. When I did initially started the project, it was just running on plain old Ubuntu install. It's a Raspberry Pi 0W is a hardware, so it's a wireless Raspberry Pi about the size of a, stick of gum, maybe a little bigger. And I was just running the standard, it's either Raspbian or Ubuntu, I forget, but just a regular Linux install. And then I just developed and ran this Elixir application on top of that. It fetches the METARs down every hour or so. It does animations, it changes the lights, and that's pretty much the whole thing. Now, rightfully, someone brought up the question last time, like, well, why didn't you do it in nerves, or is this done in nerves? And the reason I didn't originally do it that way is just because, I don't know, it was too many new things happening at once. I wanted to just get it working. And it was working fine for a couple of years. But I wanted an excuse to use nerves, learn nerves. There's a lot of, people talking about it now, and it seems really cool. So this is a good excuse to get familiar with it. So I just wanted to talk a little bit today about that sort of what that process was like, and some things I learned, some problems that I had, and so on. And this is episode 6. This is originally when I sort of introduced the idea. One of the first problems I had when converting the project was that I'm dealing with two different frameworks at once. On one hand, it was just a plain old Phoenix application that I generated with Mix Phoenix new, and then on the other hand, I've got a nerves project boilerplate that was generated using that, those generators. So how do you mesh these two things together? You can't make a new Phoenix nerves project. It's not a thing. But so because I was more familiar with Phoenix internals, I felt a lot more confident. Okay, let me just make the nerves project, use its generators, do what it wants to do, and then piecemeal just move over all the individual pieces of Phoenix, the dependencies, the configuration, the build systems, and all that stuff. And that was just basically like playing whack-a-mole. There's a lot of pieces there to get Phoenix working, but I was able to do it, much to Phoenix's credit. Like, it is very modular, and you can leave a lot of things out. So, and you can only include what you need to. So that was actually a pretty successful process. It was starting with this nerves thing, and then just slowly moving the Phoenix pieces over until it worked. And now the core of the application is not Phoenix. It's just dealing with hardware and stuff. And all those libraries still continue to work the same as they do on Linux, as they do on nerves. So that was great. The biggest headaches really, of course, just come down to JavaScript, getting the build system working. I really wanted to add live view support, so I had to upgrade all the dependencies and get ESBuild working, and just that same old story with getting updating the latest and greatest thing. Spent most of my time, honestly, just updating dependencies and figuring out how to get the build system to work, because you sort of have to build it locally and then push it to the device remotely or wired. And so figuring out the difference between like a mix environment versus a nerves target was a little bit of messes with my head a little bit. I'm still not 100% sure on when I should like do something in dev versus prod, and when it should be the host target versus like the device target, that sort of thing. Still kind of nebulous. But I think I was able to work out most of that and get it working. One cool thing I was able to do. So the whole reason was I sort of wanted to iterate on this project, improve the software. But beforehand, the development cycle was extremely slow because I had to make the change, compile it, or work remotely on the device and restart it. And you're like, it's really, really slow to iterate because you have to this sort of like loop cycle where you develop something locally, you push it, and you just have to like wait and see if the changes you made were successful or they're what you want. And that's not really a great way to be productive. So after I got it working on the device, I realized that since it's just a Phoenix application, it can run locally. The only thing I don't have on my local, desktop computer is hardware. I don't have Raspberry Pi I/O pins. I don't have access to all of the different, hardware devices that the Raspberry Pi does. So what do we do when we want to run things that we, don't want to have access to? We use mocks. We use behaviors. We use we fake things out. And so the same way that you would like mock out an API for a test and stub out some fake behavior, well, I did that with hardware too. So every access to an I/O pin, access to the sensors that read the light levels in the room. I used our very simple like behavior pattern and abstracted that stuff all away. So now I can literally run the same code base locally with fake hardware, and it all just works. And that allows me to iterate on the user interface. And then when I'm done and ready, I can just do one push to the device, and I have confidence that it will work. So that was a fun little excursion. And it really makes me want to work on it more because it's so much easier now.
Is that in fact the board behind you that is like on the wall, the glowing lights back there?
Yes, that is the one.
Okay.
Yep.
So you simulated that with little dots on your screen?
Yeah, exactly. I just used, I haven't fully fleshed it out yet, but my thought process was that each piece of hardware could just be a gen server that keeps track of the state, and it just kind of simulates, whether I/O is on or off, or whether the color of the LED, that kind of thing. You can abstract it like however you want, but the idea is you basically, just re-implementing hardware and software as like a fake simulation, basically. Yeah. Oh, I forgot to mention another cool upside of this. So there's some animations that happen on this, and the Raspberry Pi 0W is a very anemic processor. It's single core, it's clocked very low, and so there's not a lot of resources available to doing fancy animations because it requires updating LEDs very, very frequently. And so lots of times, this would basically not freeze, but it would run extremely, extremely slowly because all the CPU is literally just consumed by generating these animations. But by switching from a Linux-based OS to the Nerves very slim OS, there's way more headroom. So the animations actually run faster, run smoother. It doesn't chug nearly as much because you don't have all those system resources being used up by the operating system. So that was cool.
Could you talk more about like your first impressions with Nerves?
Oh yeah, that's a great question. So yeah, this was my first time playing around with it. I found it very easy to get set up. The hardware support was very good. Everything basically just worked by following the documentation. The initial time you set up the Nerves sort of operating system, you have to flash an SD card and then, put that in your device. But I wanted to basically, as quickly as possible, I transitioned to pushing the updates over the air, just over Wi-Fi. So I just configured the Wi-Fi as quickly as possible. So then I could just leave the device running anywhere and push the new firmware to it. So yeah, that was all really good. And once I figured out how to get access to the logs, that was helpful using the ring logger library that they have in there. And ring logger is interesting because it's a replacement for the log, like regular logger backend. But instead of writing to disk, the ring logger actually just keeps it in memory. And so I think they call it ring logger because it might be like a ring buffer or a circular buffer or something. But the whole reason they do that is, yeah, you only have a limited history of your logs, but for an embedded device, if it has flash storage, if you're constantly writing logs to it, you might wear out the flash storage. And so they optimize for that by not writing logs to disk. They just keep them entirely in RAM, which I thought was interesting and not something I ever would have thought of.
Cool.
The only problem I've really had is a few times the device became unresponsive and required, pulling the power and restarting it. Probably something I did, but it doesn't really, I don't really have confidence that if I was gonna like make this a commercial product or whatever, that I want to know more about those failure modes and what happens when it does become unresponsive and what you can do about it besides just pulling the plug.
Have you tried turning it off and on again?
Exactly.
When I was working on the Lullaby player I made a while back, I didn't really have like a hardware abstraction per se, but I did want to be able to develop as much on the machine, on my laptop as possible. The things that the key presses would do, like play and pause or whatever, I was able to do from IEX. I just had functions that it would call. And that did make it easier to develop, but I never actually got to the point of pushing updates over Wi-Fi. I was always like writing to an SD card and then sticking it in the thing and booting it up. It's a really painful development cycle for sure. So if I were to pick that back up, I think the setup that you have sounds good.
Yeah, definitely. One thing I don't know is like, if this, again, just thinking about a commercial product or just even like making a device to give to someone, how you have to come up with some really complicated way to get it to connect through their Wi-Fi, basically, right? Like if there's a configuration piece, you kind of have to sort of reinvent that wheel. How do you get, credentials for your Wi-Fi on there, right? Because the way I did it, it's literally just, burned into the config of the application. But I don't know how you would sort of white label something and make it configurable for them in an easier way. Maybe the thing can phone home to again, how do you get access to an API if you can't get on the internet? So that's an interesting thing that I don't know really the right way to do it without doing the hacky thing of like, hey, let's spin up a ad hoc Wi-Fi network and you connect to it and you give it some info, that whole thing, right? Like you do with so many IoT devices these days.
Yeah, I don't know the answer to that. I know that the Nerves people have done a lot of work on trying to make deployment and updates easier with stuff like Nerves Hub. But as far as like getting Wi-Fi access in the first place, I'm not sure. That maybe some of the use cases they have in mind are where you ship a cellular connection with the device and it's just plugged into it. I don't know.
So yeah, that was it's been a fun project. Again, I'm super happy that it came out. It's been very reliable. I haven't had any problems with it. And like I said, it's more performant and I have a better development lifecycle. And another benefit, the README file. So originally I documented every single step you had to do, install Raspbian, install the dependencies for Erlang, install all the stuff, get the code on there, configure it, blah, blah, blah. Now the README like fits on one screen. It's just, Nerves or mix firmware, mix burn, mix upload, you're done. So that's just some nice confidence in future proofing that for myself. You don't have this whole brittle setup process where it's just run the mix commands and plug it in and it's probably going to keep working. So yeah.
Do you treat your map like a lamp? You just like come in your office, turn it on, and like when you don't want to use it, you just flip off the switch and leave?
For a while, I had it on a remotely controlled switch, so it would go on and off on the timer. So like at the end of the day, it would just turn off, and then it would turn on in the morning. I don't know why I did that. It's not like it uses that much power, and it's kind of cool to have it all the time. So I just think of it more of like an ambient, it's like to bask in the glow. It's actually one of the things on my to-do list forever was like put a schedule on it so it could automatically turn off and on a schedule. But PRs are welcome.
Yeah, it's a nice, like you said, it's a nice ambience. It's like half useful, half decoration. So right now it's like all kind of for me it looks like it's a bunch of turquoise lights. So what does that mean?
They're all green.
How's
so
the weather?
It's a VFR day today here. Really clear skies, not a lot of wind, no clouds or anything. So they're all green.
So if the wind starts blowing and we get some stormy weather coming through, how's that map going to look?
Yeah, so the green is VFR, blue is marginal VFR. That's when the clouds start lowering. So between 1,000 and 3,000 feet, if that's where the clouds are, it's going to be blue. And then below 1,000 feet, if that's where your cloud ceiling is, then they'll be red. And then if it's really low visibility or really low clouds like fog, or snow, that kind of thing, then they'll be the magenta color. So those are the 4 sort of unofficial colors for those different categories. Lots of different weather apps use the same color scheme.
So if it's all magenta back there, you're not going to be getting in a plane.
No. Some days you get like a bingo where you get like a few of each color, especially in the springtime.
Would you accept a PR if in 3 weeks it simulates the apocalypse, give you a little scare? April 1st.
Just a slowly expanding radiation cloud.
Yeah, you should absolutely. That should be like, you should have a button under the table when people come over, you tell them about it. Oh yeah, so it simulates. Oh, what's that? That's not supposed to happen. The whole thing just starts flashing bright red.
So definitely some possibilities there.
Have you thought about other data that you'd like to visualize in a similar fashion?
It's a great question. I've always liked ambient visualization devices. One of my first ones was I actually had a traffic light, and that was fun because just 3 lights. This is like legit traffic light, like probably 3 or 4 feet tall, aluminum. And originally I used it for like displaying like email notifications and that sort of thing. And I really like the idea of that. I'm not really sure on a map what else you could do. Maybe traffic, that could be a cool one. Maybe if you had like a globe, you could display, who's visiting my website right now, that kind of thing, right? IP addresses of active visitors on your site, all kinds of possibilities.
I'd like to have a traffic light in my house that's like noise level of children, like children, it's yellow. Children, it's red now. You have to be quiet.
Father's patience. It's just a turning dial.
Yeah. They had that in my elementary school lunchroom, but I'm pretty sure as a human, controlling it.
That would just be a challenge for my boys. How high can we run up the score? So it would backfire.
It's so true.
Could you talk more about the actual hardware involved? I haven't done any embedded or gotten to play with nerves yet, so I'm really curious. Like, how do you begin getting these 2 things to talk to each other? How do you actually hook up all of that hardware?
Yeah, that's one thing I really should put in the repository. It's just like a schematic and parts list of this stuff. But there's actually very few components here. Again, it's the Raspberry Pi 0W. Good luck getting one right now. They're just challenging. The LEDs are also, they use a standard LED sort of format. They're called, also known as Neopixels. There's another one called dot stars, which is slightly different. But Neopixels are sort of the one that have been around the longest. They have all different form factors, strips, individual LEDs, 2D arrays. And the nice thing about that is they're so ubiquitous that there's libraries for communicating with them. So like the library used here is called Blink Chain. And so it knows how to talk to the LEDs. You just have to tell it, hey, LED index, whatever is this color. And it just kind of does it. So, and those are just, those hook up regular to the IO pins on the Raspberry Pi. The power supply is just a 5-volt power supply. It's a very beefy one to power, to provide power to LEDs. And the only other real piece of hardware was the light sensor, and that took a little bit of electrical engineering knowledge. But basically, it's a resistive it's a photosensitive resistor, and so when the ambient light in the room changes, it changes basically the voltage across that component, and we can detect that in the Raspberry Pi, and then adjust based off of that. So there's lots of like simple circuit examples for that kind of thing. But yeah, it's known as a photodiode, or I think it's a photoresistor technically. But that's really it in terms of hardware components. Yeah, Zach?
How granular is the like the measurement on the photoresistor piece? Like, is it essentially, does it just measure like a high-low once it gets dim enough, or does it have like a range where it's kind of adjusts things?
Yeah, I do have it configurable because, just so you can tweak it, and it uses a technique called hysteresis, where, like, let's say this color range is the brightness range from 0 to 100. So maybe once the brightness gets above 60, then it sort of latches high, and then only if the brightness drops below 40 do you count it as low. So that way it leaves you a little bit of wiggle room there. So if you're maybe right on the edge between like 60, 59, 58, 59, 60, it's not flickering, right? It just kind of, once it reaches that threshold, it stays in that threshold until it drops below a new threshold. So that's a little technique that I use to sort of, those two numbers are configurable. With photoresistors, it is tricky because light is like logarithmic. It's sort of, you think of like decibels, how like with an earthquake, one number on the Richter scale is like a doubling of power or whatever. It's the same kind of thing with light, where a little bit of light change generates to a large linear change. And so you have to sort of account for that when you're sort of doing these things. You can sort of basically remap the changes in the values so that it's something more reasonable that you would expect in linear. I don't know if that made sense. Basically, you lose some sensitivity when things are like really bright or really dark because you can't really detect those changes. Our eyes can detect the changes really easily, but it's a little bit harder without having a big dynamic range available to like measure.
Cool. Anything else on that before we move to another topic?
I will post a link to the repo, the old one. I basically started over from scratch, so I just left the old one there. But the new one is METAR map nerves, and I'll put a link in the show notes if people are curious about how this crap all works. There's a link to the photo album that shows how I built it as well.
Cool. And it does look awesome.
Thanks.
Brooklyn, you wanted to talk about some things you've been working on?
Yeah, this will probably be a pretty quick thing. I don't know how much detail there is to go into it, but been getting to play around a lot with Kino and LiveBook. So LiveBook, that's what the DockYard Academy course is going to be built on. You start up a LiveBook server, it shows all of your different .livemd files, and then you can run and evaluate Elixir code alongside Markdown instruction. Kino adds some utility to that, where you can do like form inputs, you can do data tables and graphs, and so it adds a bunch of different visual elements. And one of the awesome things about Kino is that it lets you create now your own custom widgets. So there's a Kino.js and Kino.js Live module that allows you to render your own custom HTML. And with the Kino.js Live, you actually get two-way communication. So you can have your Kino.js Live module with Elixir, and then you can go back and forth communicating between your HTML JavaScript asset and your actual live widget. So that has let me build some fun stuff. I'm looking for more things to actually build with it because I'm just kind of scratching the surface. But one thing it let me build was a validated form. So as students are entering in their answers for a question, maybe they're doing comparison operators, and it gives them a question. Okay, what comparison operator is going to evaluate to true when it's 7 something 7? It's like, oh, well, double equals, that's going to be true. So they type that in, and once they get the right answer, it highlights green, giving them that positive feedback, so they actually know, oh, okay, I've done it correctly. And it's a little bit more intuitive. Like one alternative would be to run an XUnit test or something on their input, but then you have to go read that test. It's not immediate. It also like doesn't trigger those good brain, oh, it's green sensations. So it's a little bit more exciting when you see it. The other thing I got to build, which was a lot of fun and super useful for some of the stuff I want to do, is I keep calling it Live Slide because that was the original project name, but now it's just a Kino module. It's called Kino.Slide. And what it allows you to do is have a slideshow within your lesson. So you can power images with it. You could power different markdown with it. It'll return whatever you give it, as long as you give it a list of some information. It can even do like, it can even return numbers if that's what you wanted it to do. And so you give it some sort of a list, you say, okay, make a new slide, and then it will give you a button for every different element that you define. So you give it 3 different images that you want the student to cycle through. They can go 1, 2, 3, and it'll show those images as they click through. So that was designed to replace some animations that I made. Another cool thing that Kino lets you do is make animations. So that's something that my horrible sense of style and design has had a lot of fun with, making all sorts of different animations to show processes and things like that. But every once in a while, I wanted to do an animation that was for code. So I wanted to show, okay, like we have a case statement. How do you really intuit and understand what a case statement is doing? Because when you already know what it's doing, it's really difficult to walk through it and explain. It's like, this is just a bunch of symbols. If I don't know what those symbols are doing, you're telling me, oh, it matches on this. Like, why? Why does it do that? What is it doing step by step under the hood? How can I visualize that? And my first attempt at solving that mental problem was animation. But the problem with that is you'd evaluate the whole notebook. Typically, your animation would start playing without you actually seeing it. And then by the time you scroll down to it, you're halfway through that animation. You're in the middle of a sequence. You're like, I don't know what's happening. And then maybe you'd catch the start, but it's either going so slow that you're like, okay, I'm just waiting for this to go back so that I can understand it, or it's going so fast that you don't actually have the time to read the text. So I was thinking like, okay, maybe we could provide controls or something like that, but decided that just a slideshow would be a lot better. So now you have your code example, you have your case, and it'll walk through step by step. Well, here's how that case statement is evaluating, or here's how a function is executing. Here's what it's doing under the hood. And hopefully that will help students kind of understand the actual flow of code. I was very surprised to find out that it handled images. It was one of those things I wrote up specifically for Markdown and code. And then I asked myself, hey, will this work with an image? I was literally walking through it with someone kind of demoing, and I'm like, oh, can it do an image? And I'm like, I don't know. Maybe, let's try. And just put an image in a little Markdown block. And yeah, it totally works with images. If I want to do, for example, I'm not a big lecturer. I think lecture has its place, depending on how it's used, but it's not always a very good content delivery mechanism for information. So these slides would let me actually do my lecture within the LiveBook. If I just convert like a existing slideshow into images and then render those images, I can walk through my slides in the actual LiveBook as I'm talking. That's like a theory. I don't know what's going to be the best solution, but that would mean that if students want to go back or they want to follow along, they would actually have access to that, and I don't need to give them my, Google Slide or whatever. So yeah, there's lots of cool things that it kind of opens up. And with LiveBook and Kino now, you can do basically anything you want. You can make any custom widget. So I think there's a lot of exciting possibilities to explore there.
That's really cool. I like that you're thinking about how to help students see, like, walk through what is the case statement doing, because I think that's really important. I remember when I was first learning to program, my mentor walking me through like a for loop, where at each round you're incrementing I, and then like, okay, you get to the next round. Now what's going to happen? I is 3. What's it going to do? just having to slow down and think at that pace. It feels kind of like I'm an idiot. Like, okay, now I is 3. Is I greater than 4? No. but having to like do that step by step and think like a computer was really helpful. And just knowing that that's how you do it. And sometimes you still have to get back down to that level and or even even if it's not the details of code, it can be architecture. It can be like, well, what happens if, okay, let's say this message arrives and then this message arrives after it. What's gonna, how's the system gonna react to that? Or let's say that this is in the middle of happening and this fails, then what's gonna happen. Just getting down to those nitty gritty details is really good. So I like that you're sort of teaching that kind of detailed walkthrough. I think like a computer.
It's very easy to take for granted when you have done it long enough that you can just hold some code in your head and kind of like walk through how it would evaluate and imagine that. Or you have the debugging tools to actually execute the code, watch it walk through, and you can figure out that way if it's particularly complex. But I've gotten some opportunities to tutor, which I'm very grateful for, because it helps with that curse of knowledge. So the curse of knowledge, by knowing too much about something, you forget what it's like to not know about that thing, and then you become incapable of explaining it because you just lack you use terminology that doesn't make sense. You don't understand the perspective. So I try to eliminate that bias as much as possible. And yeah, I've gotten to sit down with a student and like just walking through, like, calling a function, here's an argument, what's going to be the value of that parameter. That's like a hard thing to wrap your head around. It's not this intuitive, even though it's like a fundamental kind of basic building block. There's a lot of stumbling blocks for people early on. So hoping to eliminate as many of those as possible.
When I'm looking through the Kino docs here, and this is super, super interesting. One thing that immediately comes to mind is scenic, right? And that's a way to sort of render pixels on a screen. And I know Brian's been working on some fun things with that as well. I don't want to spoil his thing if he's wants to talk about it at some point, but I was just wondering if there's if you had considered using scenic for any sort of illustrations or visualizations here, or if that's even a good tie-in. I don't even know.
It might be a great tie-in. I don't have enough scenic experience to say it, but thank you for introducing it to me, because now I can go in, try it out, see if it's good. A lot of the times I'm using Kino Animate with a combination of Markdown to do some animation. Like I recently animated a traffic light to talk about state. So I wanted it to go through, red, yellow, green. So my solution, and so far my needs, have been simple enough that I can just render some Markdown, put that in an animation, say, okay, like, have these lights, all of them will have a black background, and only apply the background color whenever it's that particular light's turn in the animation. So that has been kind of, simplistic stuff. There hasn't been anything overly, I try to keep the bites short and sweet, because I can spend a lot of time on an animation and it'll be 2 minutes of student time. So I try to keep my things as high impact as possible. The very cool thing for me with these animations and with these widgets is that it opens up things that I can do in the long term. Like I can make really interactive exercises with like a full UI all within LiveBook. Theoretically, it would just be an amount of effort that for the first run through the course isn't a good cost equation. But that means we can always be adding things. There's lots of creativity. There's a part of me that's even considering teaching the students how to use Kino and LiveBook. But yeah, that's cool. I'll check out Scenic. Thank you for that idea. I am looking for project ideas, things that I'm now kind of done the fundamentals section of the course, and I'm working on getting them to actually work with Elixir locally. So far, I have a few different project ideas, like a weather CLI and distributed rock, paper, scissors, and things like that. But I'm looking for other ideas there if people have them.
I got into doing the Advent of Code at the end of last year, and which is daily code challenges throughout the month of December. And they get increasingly difficult as the month goes on, but they the first like few days worth of challenges I think are like ripe for maybe like fun code challenges that might teach concepts, especially in functional programming. Some of those problems are very, very well suited to purely functional solutions for things. So those and they're fun, I think. So it might be something worth checking out.
Jose published his live books of most Advent of Code days on his repo. And for many of them, there's also Twitch videos of him solving them. And for some of them, there's even like an edited down YouTube version of the Twitch video.
That's a great idea. Yeah, that would be super useful. There's a few different things I pull inspiration from. That's something I should be pulling more inspiration from. Thank you.
I don't know. I haven't tried to do this in Elixir, but it's one of the most fun things I've ever programmed, and it goes back to like a demo that somebody did for me in college back before I was even doing programming, but my roommate was, which is a Markov chain generator, which it takes in text and then splits it up based either by word or by character, and then it sort of like reconstructs probabilistically. So like let's say you have TH, it's very likely that the next character is going to be E, but it could be A because it's building the word that, or you can do it word by word. And so you take whatever text you put in, it's going to spit out text kind of similar to that, sort of statistically. So I did this in Ruby a long time ago, and I just pulled up the README. So I put in the Constitution of the United States, and then I spit out word by word, a word by word Markov chain, and it says, with foreign powers and to all other shall be failure the House of President, the disagree to that the two this Congress of them, or from the people of the absent transmit, stuff like that. It's like, it sounds kind of like the Constitution, but it isn't. You know?
That's awesome. And so is it just running through like your text and then taking the first couple letters of each word and then applying this function to each?
So in this case, it's split word by word. So it's like after the word foreign, what's likely to happen? Well, powers happens after the word foreign. And then after powers, and is a likely choice. So it chose that. And it's random, but it's kind of probabilistic, right? So if you do it twice, you're going to get different output. But then if you have it split letter by letter, then you get nonsense words, but they look like English words, like the United of No Moro Mosterm, OSTERM. That could be a word, but it isn't, right? But it looks like an English word. Office President, he united, noon the senators, under subjection, shall taker supremo value, shall nor it. like total nonsense. But you know, if you put in Spanish text, you'll get something that looks like Spanish, but isn't, you know. So anyway, that's kind of a fun thing. And the concept is pretty simple. You just break it down into chunks and then like score how often you've seen them, and then you produce something that follows that distribution. So I don't know if that would be a fun. I don't know if that would be too hard or too easy or too, I don't know, whatever. But it's pretty fun to see it spit something out. You're like, I made it do that.
That's really great. Yeah, anything that is enjoyable when you're done with it like that is a fun thing for you to come back to and use. That's a really cool idea. I'm looking for more on like a string manipulation section. I've kind of skipped it and I want to circle back to it because I think that's an important topic. I think that would be really good as like a lab or something like that.
I enjoy writing code that like makes me laugh in the end. So I wrote a Rust package for generating anagrams, and that takes a lot more work because it all has to be legitimate words and everything. So that's why I ended up having to do it in Rust to make it perform it. And also it was an excuse to do it in Rust. But it's really fun to be able to stick in some random phrase. Like I put in Rust programming, and anagrams of that include grim gun port arms and asymmetry foe and tarring prom mugs. So the Rust programming. Memory safety, me, my artsy foe, and ye soft yammer, and format my eyes. So
in the book Dave Barry in Cyberspace, which was written in the mid-90s, that was one of his recommended programs for new computer users, is an anagram generator. Some good ones in there. He even did a challenge where he had someone at the like Washington Post challenge them to write better anagrams in the computer. So yeah, good stuff.
That's awesome. I think that's actually probably where I got that idea, because I was a big fan of Dave Barry, and he would crack people. He'd be like, you know, mention some politician, and by the way, their name can spell something that sounds like vaguely immoral or something.
Ross H. Perot is like short poser.
Yeah. Yeah. So yeah.
What filtering mechanism? Because I actually have an anagram exercise. Funny enough, in it, but I haven't imposed the restriction that you have to generate actual words. So it's more of a like permutation generator. So what mechanism do you use to actually ensure that the output is valid? Are you like going to some dictionary API, or how do you make sure that those words are actually words?
Yeah, so I have a word list, which is you can use like I always forget where the file is, but it's like etc. dictionary or something like that. There's a word list that ships on your Mac. It's just every line is an English word. So, but you can specify the word list that you want, and I've set it up so that it prioritizes words at the beginning in forming things. So if you're like, I want to make, poop joke anagrams, then you can put poop words at the beginning of the file, or if you're trying to make something come out with politics or sports teams or whatever, you can put that at the top of the file. So it prioritizes that way, and then you can also tell it like how many you want it to build. And but this is on crates.io/crates/swappy. That's the package. You can cargo install swappy and run it if you really want to. But yeah, so you can specify that stuff, but it's very expensive. It's a very expensive operation to go through all the words. I mean, for every actual anagram it generates, it sometimes will consider millions of possibilities. So it's just crazy. Because it's like what can I build with the letters that I have left, and then is that a valid word? The details of the algorithm actually have fallen out of my head because it's been a while since I worked on this. But I know I've done it before in I tried to do it in Elixir. I did it in Ruby, I think. But Rust is I think this is the final version because it's fast and it's fun.
That's awesome. Yeah, I think that'd be a great for the section I'm working on right now, actually, where they would do that locally, get to have the file, have to load that in. Thank you.
Have you checked Elixir track on exorcism.io?
Yeah, that is my Bible.
Oh,
sure.
okay, yeah.
I'm on exorcism almost every day through
nice.
brilliant ideas there. So
yeah, they have some pretty interesting exercises that are not like cross language, that were crafted for Elixir specifically, and they're very good and interesting.
Yeah, agreed. A lot of my exercises, I'll admit, take inspiration from those and then apply some nerdy twist to it or something like that.
Cool.
Often, if you just add the word D&D to the start of the title, that's basically the exercise that I did.
Elixir Roundtable can be rearranged to spell unreliable dirt ox, just so you know.
That should be the new title of the podcast.
Episode title right there. Do we have episode titles? We should.
We do.
We use numbers.
We definitely do.
We should have. Oh, we do? Okay. I thought it was just like Roundtable number 1, Roundtable number 2.
It was for a while. It was the lazy system, but I think we're gonna have titles now.
I think we just found it.
Oh yeah.
All right, so let's move along. Mike, you've been working on Flame On. We talked about that before. You said you wanted to share a couple new things.
Yeah, so as we mentioned in the last one, Flame On library, we released it a couple weeks back. It's been going well. It seems like a number of people are using it. Got some error reports back from it, and then we actually used it in an internal project for some architectural analysis and profiling on a project. And through that process, we're able to identify what was going on in the underlying library that we're using that was causing this issue. It's a really, really interesting problem to dig through. Basically, we're using eFlambe under the hood, and how that works is it takes your Elixir code and swaps it out with a mock version that starts tracing and then calls into the original module and then stops tracing. And we kept running into this issue where when it would try to stop tracing, or it would when it tried to unload the mock, it would crash and it would just stop. It would say it's not mocked. And initially, it was thinking it was something to do with it, multiple requests firing and one mocking, the second one failing to mock, or the second one remocking, and then the first one unmocking, and the second one saying, "Hey, it's not there." Turns out, actually, it was with this project we were working on, actually with Zach and Rockwell. Realized it was actually a recursion issue. So when it recursively called into itself, eFlambe was smart enough to say, "Hey, this is already tracing, let's not start a new trace. But then at the end of the call, it would still try to unmock the code, and so the internal call would unmock the code, which would result in the flame graph getting cut off. But then it would also throw an error when the outside external one tried to unmock, because the internal call had already unmocked it. And so figure that out quick. I had to dive back into Erlang and figure that out again. It's been a while. Got that fixed, pushed that up to eFlambe and a new version of FlameOn using that. So the results that we were then generating after that were much more reliable. We got full flame graphs and no more of those errors. So if you are one of the ones that tried that out when it first came out and you ran into those issues, try it out again. I think 030 is the latest one that has that fix. But yeah, definitely love to see that get some use and see how that's helpful for people. And if you haven't heard about it, it's basically a flame graph generator that will allow you to that can be dropped into live dashboard or a live view through a live component.
It was interesting watching you debug this, and I learned a lot. And I had a conceptual knowledge in my head that the beam has tail call optimization, right, where the stack won't grow infinitely. But I never thought that like there are situations where maybe you don't expect it, but it's still optimizing out the tail call, even if you're not like just doing a typical recursive thing, right? And so lots of times things will just disappear because even if you're not expecting it, right? If you're not doing some recursion thing, it can still happen to you. It can still be optimized out, which I thought was really interesting. And that I also learned why sometimes things don't show up in the stack trace is for that exact reason. I don't know what I thought was happening there, whether it was just some bug or something, but it is super annoying when it optimizes out things out of your stack trace and it makes it difficult to find things sometimes. And I know that issue has been brought up more than once in the past, and I guess it's basically unfixable.
Yeah, no, that was something that for me was frustrating. That the idea, so it's helpful obviously that the tail call optimization so the stack doesn't overload when you're recursively calling stuff. But the idea of dropping your path back, especially when you're trying to debug issues and working through where in the code this blew up, just having like basically a huge section of the stack trace, which would have been useful, just gone, and having to kind of work your way back up actually from both ends of the gap to try to figure out where the code went. It is annoying when trying to track that stuff. But yeah, when it comes to the flame graphs, it's actually interesting because you actually lose out on information that is you would need to track stuff down. And even in the example that I wrote for I think for the blog, I had 3 functions, foo, bar, and baz, but they were all tail call optimized out initially. So when you ran it, you couldn't actually see them in the flame graph because all you saw was the sleep, which they actually called into. And so I had to change it so that it would do the sleep and then return some other random value so that it wasn't tail call optimized out. Yeah, and you'll actually see that in the tracing in the background. You'll see that the way tracing works is it basically every time it calls into a function, it sends a message saying, entering this function, and then returning from this function. And one of the issues is that I'm still working through trying to identify this, but in eFlambe you'll get a slew of unexpected return to calls where it's working its way back up the stack, but it doesn't know that it was there, and so the thing that's expecting to be on the bottom of the top of the stack, whichever, isn't the right thing. So you'll get warnings dump out about that. And yeah, I mentioned this to Jose a while back. Is there a way to say, hey, for this, can we run without dropping stack frames and just leave it on the stack? And he said no, there's not really not a way to do that that's easy. But That would be something that'd be interesting if we could, if there was a way to say, hey, run the code and don't drop off tail call optimized stuff, because it's helpful for this. Obviously you wouldn't run that in production or anything like that, but for debugging it would be super useful.
Yeah, I've never really dug into when that happens. I've noticed that sometimes things are missing from the stack trace, but I haven't dug into why that happens. Now I want to go like construct an example and raise an exception and see what I can make not show up.
Yeah, like I said, it's information that would definitely be useful if we had it, but there's obviously reasons why it's beneficial to drop it.
Yeah, it would be great to have a flag that says don't do that this time.
Yeah. But I think that's I'm assuming that's deep in the beam stuff. Yeah.
I mean, you would definitely want it to not grow the stack infinitely when it's recursing over this in the same function.
Right. Yeah, something like that. But that at first I was like, well, only add one entry for any given line to the stack. But then the problem is if you're looping through 3 calls, right? And it's then now do you add those in? So it need to be smart, and that's obviously going to add overhead, and who knows what other things are relying on that sort of a thing.
Yeah, always the painful trade-offs between speed and readability and usability and all that sort of stuff. Well, I think that wraps it up then. Thanks for listening, watching, or otherwise consuming the Elixir Roundtable, however you do that. If you've enjoyed the show, please make a cardboard cutout of any participant and tell it how much you enjoyed their comments. Thanks for coming on.